Prototypers. Last time we learned about analog input, like this slide potentiometer or this rotary potentiometer, which has the ability to change its voltage levels between 0 and 3.3 volts, which are then converted by the CPX to a value of 0 to 1023. With digital input, like these buttons, they're either on or off, where on just corresponds to 3.3 volts and off corresponds to 0 volts. So let's get started. You're going to need your alligator clips. Let's just use a yellow one like before, along with a red one, which will hook up to 3.3 volts, and a black one, which we will hook up to ground. All right, so this is the 3.3 volts. And we have, which there's also 3.3 volts right here. They're the same. And then we have ground here and here and here. You can use any of these, but we're just going to use one of them for now. They're all the same. And then we're going to use A1 as our input, just like we did with analog input. You can actually use A0 for the digital input as well, but we'll stick with A1 just as before. So hook up the yellow wire to A1. Hook up the red wire to one of these 3.3 volts, and hook up a black to one of these grounds. I'm just going to use the same ones we were sort of using before. Now remember, don't touch the red to the black. So don't touch 3.3 to black. It'll short your CPX, but you can touch the yellow to black or the yellow to red. And in fact, that's what we're going to do to start. We're going to just make a basic manual button by moving the yellow from red to black, kind of like what we did with analog input, but we're going to read it as digital input this time. So let's get started. We have to go over and open up our MakeCode. So here we are in our friendly MakeCode. Now remember, with the analog input, we went down to advanced and pins. Well, it's the same thing with the digital input. All of these pin interactions for the external sensors are going to be right here in this red pins block. So we'll click that. Before we used analog read pin, now we're going to use digital read pin. So we'll drag that over. By default, it starts with A0, so it goes from A0 to A7. We're going to select A1 just like we did with analog input. And the first thing we're going to do is just simply print this out. So we'll do console log. And we'll read this pin value, which is going to be either 0 or high for 1, depending on what the yellow alligator clip is touching. And we'll just print that to the screen and see what the value is. So let's download it. And remember, we can click Show Device to see what these values are in real time. And then I'm going to grab my alligator clips and I'm going to alternate between these two things. And we'll see sort of how the digital input works. So I'm going to switch my screen slightly. I have to move this over like that. And then I'm going to go like, let's see, like this. So now, oops, I've got to open up the console window again. There we go. Oops. There we are. So it's oscillating between true and false, true and false, true and false, true and false. True would be when the button is down, and false would be when the button is up. And since nothing is hooked up to yellow, it's very confused. It's like, am I on, am I off? But if we connect it directly to black, which is 0 volts, and we move that little, oh, the CPX thing is in the way. There it goes. Roll it out. You can see it's just false, 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 because we keep checking, we keep checking, we keep checking, and it's just 0 volts, 0 volts, 0 volts, so it's false. Now when we unattach it, now it's noisy, noisy, and we'll get there. We'll talk about why that's noisy and what to do about it. But if we connect it now to the 3.3 volts, so that's the red wire, look, now it's true, 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 true. So that's as if we're pushing the button down. And you can directly connect this yellow alligator clip over to the 3.3 volt pad or to ground to kind of simulate like a switch. That would be like pushing the switch down would be connecting it directly to 3.3 volts. Lifting the switch up would be like connecting it directly to ground. Now, this visualization of true, false is not very interesting, so I'm going to actually graph this now. And to do that, we're going to have to modify our code a little bit. So let's go back over here to our code. And rather than console log here, we are going to read the value into a variable. So let's get started with that. Let's see. I can hide my electronics for now. Let me just go full screen here. So so that was like the simplest thing. We were just reading the value, the digital value off of A1. But let's actually set the value into a variable. And let's read it first as an analog variable so you can see what that looks like. And we'll also then read it as a digital variable so you can see what that looks like, and we'll compare it. So let's do an analog read on pin A1. And we're actually going to set that to a variable. So let's say it's A1 analog value. So set A1 analog value to the analog read of the A1 pin. We're going to do basically the same thing. But this time we're going to check to see if the digital read pin is true. It's going to be either true or false. We saw that on our console log. So if it's true, that means the button is being pressed. And we're going to make a new variable called A1 digital value. So let's just say that the A1 digital value is 1 when we press the button, and it's 0 when we don't. And like before, when we were using the buttons that were built into the CPX, we turned on lights. Let's do the same thing. It's good to have that feedback. So if the button is down, we'll set all the pixels to red. When you release the button, let's set them all to black. So that's basically our full program. The other thing that we want to do is actually log this out so we could see the graphs of it. So let's type in console here, console log value. Now we're running out of a little bit of the room here, so I'm just going to zoom out. So we've got that A1 analog value. Let's print that out. Put that in there. Say A1 analog. A1 analog, and then we can duplicate that and change it to A1 digital, and then change the variable. So what we're doing is we're doing an analog read off of A1, storing it in this A1 analog value variable. We don't need that console log right there. Then we check to see if the digital pin is pressed on A1. So we do a digital read of A1 now. If it is, we're going to set all the colors on the NeoPixels to red. We'll set A1 digital value to 1 to indicate that the button is being pressed. Else, we'll set all the NeoPixels to black and set A1 digital value to 0 to indicate that it's no longer being pressed. And then we'll log these over to console. So let's download this. All right. So the first thing you might notice, I'm going to switch over to, there it is. Oh, it's really noisy. So let me go like that. And like that. Okay, it's really, really noisy because again, it's fluctuating. It doesn't know, is it on, is it off? It doesn't know until you actually wire it in to something. So now we have grounded it. It's at 0 volts and the lights on the NeoPixel are off. And we're also graphing, we're also graphing 0. up here, the blue is the analog input and the pink is the digital. So the digital is going to go between 0 and 1, and the analog is going to go between 0 and 1023. So I just unhooked my yellow wire, and again, it's going back and forth, back and forth. But if I connect it directly to red, what do you think is going to happen? Right now, this is like someone pressing that button down. It's like pressing the button down right now, holding it down. It's at 1023. And if you release it, it would be like going right back to ground. And you can go back and forth as we did before. So that's when the button is not pressed. This is the button pressed, not pressed, pressed. Now we have noticed this noise. Look at it, it's flashing. It doesn't know what state it's in. And this is called the floating pin problem. And it's what makes digital input a little complicated. So we'll talk about that. We'll figure out what to do. And it's necessary to talk about it because otherwise we're not going to be able to hook up to these buttons. So there's something called the floating pin problem. And it's kind of interesting because your own body and the electromagnetic interference in your environment can actually affect the value that is read off of this A1 pin. So let's figure out a way to solve that. But I think this is really interesting, right? That we basically created a little button, and you can see the difference between the analog version and the digital version.